Hello viewers, welcome to add-on. In this question we are asked to explain the pulse amplitude modulation and the need of modulation. Okay, so let us start with pulse amplitude modulation. So pulse amplitude modulation is known as PAM. So P represent pulse, A represent amplitude and M represent modulation. Okay, so this is the pulse amplitude modulation. So what do we mean by that? In pulse amplitude modulation, suppose this is a sinusoidal signal, right? This is any kind of sinusoidal signal. Okay, we are representing it by like this. Okay, this is any kind of sinusoidal signal and this is a pulse train. Okay, pulse train means it is a sequence of pulses. Okay, this is the sequence of pulses. These are all these individual lines, these are all pulses, right? These are all pulses, which is known as pulse train. So this is our sinusoidal signal. We are represented by m of t, sinusoidal signal, and this is our pulse train. We are represented by c of t. Now there are two types of pulse train. Here we can see this is a single line. That means these pulses have a width of 0. Now we can also use pulses which have a width like this. Okay, so we can also use this kind of pulses. So this pulses have a particular width. We can say, let us say this pulses have a width of tau. These pulses have a width of tau and they are separated from each other by a time period of t. Okay. So in the pulse amplitude modulation, what we are gonna do, we are just multiplying this message signal with this pulse train, which is c of t. So generation of this kind of pulse train is particularly difficult. So in our practical scenario, we won't be using this kind of pulse train. We will be using this kind of pulse train which have a particular width and the pulses are separated from each other by a particular time period. Okay, so what we are going to do, we are just going to multiply m of t into c of t. So what we are going to get, we are going to get a message signal in the form of pulses. So I am drawing the outline of the message signal. This is our original message signal, and in the pulse amplitude modulation, as the name suggests, amplitude modulation, the amplitude of the pulses gets modified according to the message signal. Like for example, at this particular point, suppose at this particular point the amplitude is 0. So during this point the pulses have an amplitude of 0. Now at this point the amplitude is maximum. So at this point the pulse have a maximum amplitude. Okay. Now as the pulse goes from this point up to this point, as we can see the amplitude is decreasing, right? So the pulses will also have a decreasing amplitude. So as the name suggests, the amplitude of the pulses will get modified according to the amplitude of the message signal. So here we have drawn the outline of the message signal. So after that we will draw the pulses according to it. So this is the pulse, first pulse, this is the second pulse, this is the third pulse, this is the next pulse, likewise. Okay, so as we can see, this first pulse, this has a minimum amplitude. Okay, because the amplitude at this point in the message signal, in this point it was minimum, so this pulse has a minimum amplitude. And this pulse has a maximum amplitude, because at this point in the message signal the amplitude was maximum. So accordingly the amplitude of the pulse was also modified to match the amplitude of the message signal. So we can see that the amplitude of the pulses are getting modified according to the amplitude of the message signal, and the width remains the same. This width, as we have said in this scenario, it was tau, so the width remains the same. The time period between the two successive pulses t, this also remains the same. The only thing that changes is the amplitude. Suppose in this case the amplitude was a, so in this pulse amplitude modulated output, these pulses won't have an amplitude of a. Okay, the amplitude a will vary according to the amplitude of the message signal. Suppose if at this point the amplitude was a1, so this pulse which is corresponding to this point, this pulse with an amplitude of a1. Okay, now at this peak point, suppose it has an amplitude of a2. Okay, so this pulse which is corresponding to this point, it will have a amplitude of a2. So the pulses won't have the amplitude of a anymore. Okay, so this is the pulse amplitude modulation. Now next question is the need of modulation. So there are various need of modulation. The most primary need is to send a signal. So suppose this is an antenna and this is a receiver. Okay, let us say our receiver, we are sending the information through it. Let us change the scenario. Suppose antenna is our receiver and we are using any kind of say speaker. Okay, we are using any speaker to send our information, because our voice or any kind of sound, they are all what, they are all kind of signals which are analog in nature. Yeah, because in real world scenario, the entire signals that which we are generating or which we are dealing with are all analog signals, and they can be used in digital modulation. Then they are, the analog signals are converted into digital signals for our convenience, but we won't get into that much depth now. We will be just dealing with analog signal. So this speaker or our mouth or any kind of source that is generating any kind of signal, suppose this speaker is sending some signal and this antenna is receiving the signal. So this is the transmitter and this is the receiver, and within this there is a gap. So this is the channel. So the channel just passes the signal from the transmitter to the receiver. Okay, so the thing is, this information which is being sent from the transmitter to the receiver, it may arise as that the signal was not strong enough, right? Suppose the signal was very weak, that the signal gets diminished within the channel, it is not sent up to the receiver. So in that case, what scenario arises, that I am sending a signal, but the person who I am sending the signal is not receiving it. So this is not our desired situation, right? So in order to send any kind of signal from a transmitter to receiver, we use modulation, and by using modulation we are ensuring that the signal which we are sending can travel the distance from the transmitter to receiver. Okay, so this is a primary need, and the next need is the length of antenna. So this is the antenna, right? Suppose the length of antenna, which is L, is equal to lambda by 4. Now lambda is the wavelength. Okay, wavelength of the signal. So we know lambda is equal to C by F. Okay, so now if we are sending a weak signal, suppose we are sending a signal, first we are sending a signal which was weak. Okay, and this is sent without any kind of modulation. So suppose we are sending a weak signal which has a frequency of 200 kilowatts. So this is a weak signal because it has very low frequency. So in that case, what will be our value of lambda? It will be equal to 3 into 10 to the power 8 divided by 200 into 10 to the power 3. Okay, so it will give us 3 into 10 to the power 5 divided by 200. So if we divide 3 by 200, we will be getting 0.015. Okay, 0. We will be getting 0.015 into 10 to the power 5, or we will be getting 15 into 10 to the power 2, 1500 meter. So if we construct an antenna of 1500 meters, so this is not our real world scenario, right? Because as we can see, the antennas which are around us, they are only quite few centimeters long. Okay, so if we are sending a weak signal, the antenna should be made this large. So this is not possible. So for this reason, we use modulation to increase the strength of the signal. Now let us say this 200 kilohertz signal, after being modulated, now has a frequency of 3 gigahertz. 3 gigahertz. So now lambda is equal to 3 into 10 to the power 8 divided by 3 into 10 to the power 9. Okay, so now it is 0.1 meter. So now this will be equal to 10 centimeter. So if length is equal to lambda by 4, so lambda is 10, so 10 by 4. Okay, so if we do it, 2 2s are 4, 2 5s are 10, so 2.5 centimeter, which is very much within our possible range, right? Because constructing an antenna which is 1500 meter, or we can say 1.5 kilometer antenna, so this is not really possible. But constructing an antenna which is just only 2.5 centimeter, this is very much possible. So this is the most primary need of modulation. Okay, so this is the most primary need of modulation, right? And another thing is multiplexing. Multiplexing means, suppose I am a person and there are 10 there are 3 or 4 persons talking around me. So this is not the case that I am considering I am in a crowded area. Suppose I am in a room and there are 3 persons around me. So if those 3 persons are talking around me, I will hear the voices of 3 persons, right? So what is the scenario? Suppose I am a person and there are 3 persons around me. So these 3 persons are talking, which means these 3 persons are sending a signal towards me. Okay. And my ear, which is the receiver, is receiving all of these 3 signals. Okay. My ear can listen to all of these 3 signals, right? So what happens in this scenario, that all of these 3 signals are superimposed on each other and they are coming into my ear. So I cannot pay attention to all these 3 signals simultaneously at the same time, because I can't listen to 3 persons simultaneously at the same time, but I know that these 3 persons are talking. So these 3 signals, suppose this is signal 1, signal 2 and signal 3, these 3 signals are getting superimposed on each other. Okay. And they are coming to my ear. So this superimposing property is multiplexing, and this can be possible with the help of modulation, right? So modulation can give us efficient transmission of signal, as well as constructing an antenna which is our desired length, and also multiplexing of signals. Okay. So this is all. Thank you.